everyone, I'm K. Devita from the Department of ECE in Srinivas Raman Institute of Technology. Today I'm here to give a video presentation on permanent magnet moving coil, which is shortly known as PMMC. Here are the contents which we are going to discuss in this video. Introduction and principle, construction, working, advantages or disadvantages, application, error source and precautions, summary and conclusions of PMMC. Now let's start with the introduction to PMMC. The PMMC instrument is used for precise measurement of DC current and voltage. It is also called the D'Arsonval meter. Principle of operation. It is based on electromagnetic effect. When current carrying conductor is placed in a magnetic field, mechanical force acts on it, causes angular deflection. The deflection is proportional to the current or voltage being measured. Construction overview. Here are the key components of PMMC instrument. Permanent magnet, rectangular moving coil, aluminum former, controlled springs, damping system, pointer and scale. Moving coil and magnet system. Moving coil, fine copper wire wound on a light frame, typically aluminum. Magnet system, strong permanent magnet creates a uniform magnetic field. The moving coil is pivoted and free to rotate. Controlling and damping mechanisms. Control springs provides restoring torque and conduct current. Damping induced in aluminum core quickly brings pointer to rest after deflection. Here is the diagram of PMMC instrument. Here you can see two permanent magnets. One is North Pole and South Pole in U shape. Between them a rectangular coil is placed. The rectangular coil is placed in such a way that it can move freely on the spindle. It is made up of soft iron core wounded with aluminum former. Here you can observe two springs, upper control spring and lower control spring. It conducts electricity and provides restoring torque. A lightweight pointer is placed on the spindle, which moves freely on scale. The scale is linear. Working principle. When the instrument is placed in a closed circuit, direct current passes through the moving coil. From the principle we can say that when the current carrying conductor is placed in a magnetic field, a mechanical force acts on it, producing a deflecting torque. As the instrument is spring controlled, the controlling spring opposes this torque. As we can see, the current is directly proportional to the deflecting torque and the restoring torque is directly proportional to deflecting angle. We can say that current is directly proportional to deflecting angle. The deflecting torque helps the pointer to move on the linear scale. The pointer's steady deflection shows the measured value. The scale is linear for DC. If the deflecting torque becomes reverse, the pointer also shows 0. Advantages of PMMC instruments. It has high accuracy and sensitivity, linear scale, low power consumption, low friction and efficient damping. Disadvantages or limitations. It is only usable for measuring DC currents or voltages, but not for measuring AC currents or voltages. Higher cost than moving iron instruments. Possible temperature and aging effects on magnets. Does not show accurate value. Applications of PMMC. PMMC instrument used as ammeters and voltmeters in DC currents or voltages only. Common in laboratories, industries and calibration equipment. High precision measurement needs. Comparison with other instruments. PMMC is compared with moving iron instruments. PMMC is more accurate and costlier than moving iron instruments. PMMC instrument is only limited to DC currents or voltages, whereas moving iron instruments is limited to both AC and DC. Error sources and precautions. Aging of magnets and springs can cause errors. Temperature compensation techniques sometimes used. Summary and conclusion. PMMC is a highly accurate, reliable instrument for DC measurement. Key for precision electrical measurement.